Shake Table Lab by Christian Park and Austin Kim. To start our tower, we made a design and put in measurements to use on our tower. Our design had floors that were 14 centimeters long and each floor was 18 centimeters apart. The whole tower was going to be 36 centimeters in total height. We started building our tower by making the base in the first floor outline. Also, we had all four 36 centimeter poles made of straws. After we started the base, we put a pole down through the bottom to stabilize the tower during the earthquake. To do this, we drilled 4 holes at the corner of the cardboard and put straws through the holes, which we taped. All the poles were built up along the outside and the floors were put in, so we added poles to the inner tower for more stability. We also added X-beams to the 4 sides of the first 2 floors for more stability. We put in all the floors and our artistic roof. This tower was our final product, with a sail-like roof and rice and noodle flags. Just like we did before, we used sketch so we could label the measurements of our tower. The bottom 2 floors were both 18 centimeters apart, and the second floor was 12 centimeters away from the roof floor. 81.25 centimeters is the complete height of our tower, including the flags. To static test our tower, we used 4 250-gram weights. While static testing, we looked for any weak parts, but our tower was really sturdy. We used supports around the tower to strengthen it. To strengthen, we used poles that go through the ground to keep the tower sturdy while shaking. Cross supports were also added as well to help support the weight from the floor above. The strongest part of our tower were the center poles that held the floor above up. These poles could handle a lot of weight and were very durable. Our weakest part are the cross supports. We made it all out of multiple straws that easily come apart and are not taped very well. Tape usage was a problem on our tower. We used an absurd amount of tape and made clumps or rat nests to tape straws together. With our extra supplies, we built our artistic roof. Our roof had a sail design with flags to top it off. To see how strong our tower was, we put it on the shake table and added sandbags. We got to 14 sandbags and our tower sadly collapsed.
It's gonna fail.
What do you mean our minutes are numbers?
Dude, say goodbye.
I love my tower too.
I love that tower too.
Our tower collapsed at 14 sandbags when we were testing to see how strong our tower was.
That tower too.
Our tower also had a sensor on it which created an XYZ graph. The x-axis is the side-to-side motion, the y-axis is the front and back motion, and the z-axis is the up and down motion. The graph shown is the motions right before our tower collapsed. Hello, my name is Austin Kim, and I built a shake table tower with my partner Christian. Our shake table tower held 12 weights, which are each 450 grams. When we put 14 weights on, it sadly collapsed. The first part of the building to collapse was the side beams that fell and bent. The whole tower depended on the side beams, and when they broke, then the whole tower collapsed. If I had more time, I would have built stronger side beams to hold up the tower and support it. My favorite part about this project was working with my partner Christian, because we got to decide how we wanted to build the tower and how we wanted it to look. In the end, I was really proud of our design. I learned that it is very hard to make a tower that is earthquake resistant. Architects must have a really hard time building because it is very difficult, and being able to make a tower to support weight as well as survive an earthquake is a real challenge. Thank you.
Hello, my name is Christian Park, and I built a shake table tower with my partner Austin Kim. Our tower held 12 sandbags, which are 450 grams each, and it collapsed on the bottom left corner and the middle straw support, and they bent, and the weight was too much, so it collapsed. If I had more straws, I would probably add supports to the middle of the tower because that was where the straw bent and we needed more support there to carry the weight of the sandbags. I learned that making a shake table tower is very hard because you have to get the exact right measurements, and if you don't, it has a high chance of collapsing. I had fun with my partner Austin collaborating and using teamwork to build our shake table tower.